The environmental control and life support systems for space station have proven to be very critical for maintaining the crew health, providing them water, removing carbon dioxide, circulating the air, and will also prove to be extremely critical for exploration. So, I'd like to tell you a story about some of the lessons we have learned so far in the testing and operations of our life support equipment. Part of the ECLIS system is a device that removes carbon dioxide from the air. On space station, it is called the Carbon Dioxide Removal Assembly, or CDRA. Now, the CDRA has a counterpart on the Russian segment called the Vozduk. Between these two pieces of hardware, we are able to maintain the appropriate levels of carbon dioxide on board the space station. Each one of those systems has its own set of hardware, dedicated hardware, is located in different modules, has different operating procedures, and requires the crew to go through different levels of training. For CDRA in particular, when we developed the procedures, we met with the designers, we pored over the software documentation, and we developed procedures for how we thought it would operate, how we thought what the most likely failures might be. And we trained the crew on all of that and sent them on board. Lo and behold, after years of operation, CDRA has shown us that it not only can fail in those predicted ways, but also in some unpredicted ways. One particular failure for the CDRA had to do with one of its valves that it uses to switch between the different adsorbent beds, where it removes carbon dioxide on one cycle and bakes it out on the second cycle. This is called the air selector valve. That air selector valve became clogged. So the ground teams developed some very detailed procedures to uplink to the crew so they could change out that valve. Now, these procedures had not been trained on the ground previously, so we made sure we provided even extra time for the crews to execute this, extra review sessions, conferences with the ground. And even after all of that preparation, when it was time to execute, it wound up taking the crew twice as long to perform this activity, partially because it was the first time that they were seeing it, but also because our procedures were built off of mock-ups that did not exactly duplicate the exact configuration of the CDRA on orbit. For the air selector valve in particular, once we finally got CDRA back up and running, the problem resurfaced. We didn't have another spare air selector valve this time, so we challenged ourselves and came up with a way to clean the one that was gunked up the second time. The crew cleaned it, reinstalled it into the CDRA, and we were back in business. However, we weren't back in business for long, and the CDRA started to fail again, and that pointed out to us how reliant we are on spares from the ground, having good, clean spares that arrive at a regular basis. This is not only for the air selector valve, but for a number of other components that are part of the CDRA. So a takeaway here for exploration is for life support systems in particular, you need to have a very reliable system. That system needs to be easy to maintain without relying heavily on having resupply from the ground, because you will not have that luxury for those types of missions.
You know, one thing on CDRA that I think about a lot is it's a relatively complex piece of hardware to do maintenance on, and it's not hard, but it's like a pretty expensive piece of aircraft equipment. And you want to think about, if you're going to have the crew do maintenance, you want to think about some of the human factors things to doing that maintenance. CDRA in particular, because it has cold water going through it and we don't want condensation on it. It's got a lot of insulation that has about 50 different pieces that are all different, and they all got to kind of go on the right way. They all happen to be black, which means that you can't really show in photographs how to put it together the correct way. But sometimes, when you're doing a piece of equipment like that and you want to maintain it, there's some little tricks that you can come up with that makes it a lot easier. In particular, there was a piece of equipment I remember some years ago called ARED, or the Advanced Resistive Exercise Device. We had to remove a lot of flight support equipment to deploy it. Well, it was something like 40 or 50 bolts. Well, they made them all pink. And so all we had to do is tell the crew, remove all the pink bolts, instead of giving them detailed diagrams and pictures. It takes a lot of time on how to pull something together. So sometimes with CDRA, while it is maintainable, it used a lot of off-the-shelf components. I think there were some connectors on it that came off of helicopters that are actually relatively difficult to manipulate in zero-G. And because of how much we have to touch that hardware now, if we went back and thought about how to do it differently, we made some different choices in the requirements. Simple is better, right? Look for commonality between how your box is put together and another box is put together, because if they have the same sort of fasteners or connectors or just the way it sort of looks, we do a lot of training with the crew on sort of generic tasks. So the smaller number of generic tasks that we have to show the crew how to do, like how to torque down bolts or how to finesse a certain filter a certain way, that makes things a lot easier to deal with. A really important aspect is to make sure that you have and have budgeted for adequate ground-based hardware of the appropriate fidelity, both for allowing the engineers that put together the operational procedures to maintain a lot of this stuff, letting them get their hands on things and understand sort of how it works, but also to give you experience with operational units on the quirks of a piece of hardware before you actually fly it. There's a lot of what we learn on space station, and one of the good things about space station is we're able to put hardware on board and kind of test it in an operations environment over a long period of time, and you learn a lot when you do that. And I think that it's really easy to cut those units out early to save budget. And of course, we're all living, under budgets, and you can't have a full iron bird for everything that you do, otherwise your program will never get funded. So you got to think real hard about what you're going to put on the ground as a mock-up or an operational unit, but also have the flexibility that if the need emerges later on, that your engineers aren't fighting an uphill battle to get something added funding-wise for their own use on the ground when the need emerges. Recently, we've extended the lifetime of space station to 2024. That's more opportunity to have a facility available that allows the execution and working out operational procedures and even hardware in a real environment. And an example of someone that's been doing that recently is Robonaut, which everyone knows. Robonaut, what we do in space with Robonaut actually isn't altogether different than what they do with it in the lab. And Robonaut had a very long history in the lab before we put it on space station. But just duplicating some of the simple things that they did with it in the lab every day, separated by of course, the distance, but also the command systems and just the organization that's involved with running the vehicle, learning how to fit within that world is really what the Robonaut guys did for the first, certainly for the first year that they were on orbit. And of course, that's available to a lot of developers. And if it's something that would contribute to the project, it's definitely a good thing to look into.